Hello, good evening. I'm not sure if everyone here speaks Dutch now because there was some, but still I'm going to do it in English because my colleagues who are international wanted to see the video afterwards. So if nobody minds, then I'll do it in English. The slides are in English as well. So yeah, my name is Luc van Donkersgoed. You can find me on Twitter and LinkedIn if you want to get in touch afterwards. And I'll do a talk about building a Slackbot with AWS Serverless. There's some overlap with the previous presentation, but I don't think any of you will mind. I hope not, at least, and otherwise just shout. So the goal for my presentation today is to demonstrate how quick, easy, and cheap building services with serverless is. If I'm standing here, can you all see the screen, or am I standing in front of it? All right. So first question, why would we build a Slackbot? Well, in general, a Slackbot is a nice way to interact with technology. So you can have a background technology, it can be anything from a Jenkins server to a pipeline, or maybe some sort of queue, which we will look at later. And you can interact with it through chat. And your systems can also connect back to you and give you some feedback on your systems, which is well, a nice way to interact with technology. It's generally used for automating tasks. So you have a lot of plugins in Slack that, for example, connect to your email client, connect to your monitoring client, connect to whatever, and allow you to automate things like mark all my email as read. With one command, it just connects to your email client, marks everything as read automatically. And generally, people build Slackbots because they're fun to build and quite easy. So today, we will build a Slackbot because it's not overly complex. So it's quite easy to understand what happens, and we can, within the scope of 1 hour, build a bot and demonstrate what's possible. And well, it shows direct results, so you can immediately see what's happening. You don't need entire websites or front ends or whatever to see what is actually happening. The Slackbot allows you to do that. And once again, we'll build it today because it's fun. So what we'll build is this. We have Slack itself. Whenever something happens in Slack, it will send an event to API Gateway, which has been explained earlier today. API Gateway is a front end for an HTTP front end for systems that don't have their own HTTP front end by default, which in this case is LAMBDA. You cannot reach LAMBDA normally through HTTP, but through API Gateway you can. And then the LAMBDA function will do some read-write operations on DYNAMODB, and then send a message back to Slack. So it looks a lot like the presentation we had before. But first, we'll dive into what is serverless. And well, there's some repetition here, but well, with some repetition, you learn better, I suppose. So what is serverless? It's the next step in resource sharing. So let's say in the 80s, we had a dedicated host per service. You have one server, it runs a database. You have another server, it runs a website. But that's super inefficient. In the 90s, we went towards virtualization, in which you can have one physical server with multiple virtual machines on it, which is a lot more efficient in resource sharing. Then we moved on to containers, which are even smaller, and you don't need to manage the operating system anymore. You only manage the packages. And now we're moving to serverless. So I got some diagrams showing what the responsibility models for those things are. So starting with the physical servers, if you maintain your own physical service, your responsibility is everything from the network infrastructure to the power infrastructure, managing the physical service, managing the operating systems on it, managing the libraries and servers that are installed, and then managing the app that you actually need. So this is a lot of work to maintain. So then came colocation, probably familiar to all of you. There's a data center managed by somebody else, and you can place your own physical server there. Then you're no longer responsible for the network infrastructure and the power infrastructure because the data center is, but you still need to manage your physical server, your operating system, your libraries, and your app. So if in colocation you move to an additional server, then this extends. We went from 2 servers to 3 servers. That means you have 150% of things you have to maintain. You have to maintain 3 physical servers, 3 operating systems, and so on. If you move that to even more, well, here you have an example. You want MySQL as a database, but you want it redundant so that if one system fails, that you still have the other one. You have Nginx, your website, but you also want that redundant. And you have Redis maybe, and now you're maintaining 6 servers. So that's a lot of work and a lot of infrastructure to manage. And a lot of things that can go wrong as well. So then we come to virtualized servers. Well, this is a standard VMware image in which you have 3 physical servers, which have a hypervisor, which is the software that manages virtual machines. And in that you have your separate virtual machines. But then you still have to maintain the virtualization layer. So we're moving on to the next step, which is virtual private servers, or EC2, which is an example of that, in which the provider, Amazon in this case, manages the network infrastructure, the power infrastructure, the physical servers, and the virtualization layer. And then your responsibility is only managing the virtual server. So this is, again, a next step in how much you have to manage. But still, you're managing operating systems, you're managing libraries, and you're managing the application. So this could be a fleet of EC2 instances, for example. Well, then you can, to improve on that, put containers on AWS. Then you don't have to manage the virtual servers and so on, but you're only managing containers. Now, you don't have to worry about operating systems anymore, which is a big plus. But you still have to manage your libraries and your services to make sure that you have the correct version of Python installed and the correct version of your MySQL connector and so on and so on. That's all within your container. You still have that responsibility. And you can run it on ECS or EKS or Fargate or your own Docker environment. But then if we go to the last step in the slides, which is a serverless tool called LAMBDA, we discussed it before, which is a function as a service, or FaaS, then AWS takes care of everything, your network infrastructure, your power infrastructure, your virtual servers, your libraries and services as well. They take full responsibility to just make sure that you have Python 3.6 available. So you're asking for Python 3.6, and they make sure that you have it. That's a lot of responsibility to not have. And that's great. And that's why serverless, in example of LAMBDA, is, well, quite awesome. But there are a lot of other serverless services, like S3 and DynamoDB, which follow the same principle. There's a lot to not manage. You just take the service. So in a nutshell, what is serverless? It's a system without maintenance, because it's just your function or just your database that runs. The maintenance itself is done by somebody else. All the serverless technologies are highly available. Amazon takes care of that. So if you have your Lambda function or your DynamoDB table or your S3, you don't have to worry about availability and redundancy. It's there by default. And a super important part is serverless technologies are always pay for what you use. So if you have S3, you pay for the files that you store there and the interaction, the copying files to it and from it that you do. But if you don't use it, you empty your storage and you don't have any interaction with your files, then there's no cost. And the same with lambdas. You can have 1 million lambdas, but if you never execute them, there's literally no cost. And same with Dynamo and all the other serverless services. If you don't use it, you don't pay for it. And that's a big difference between serverless and classic servers. Because if you take, for example, an RDS database, MySQL database, it will cost you in some setup maybe $200–300 per month. If you don't use it, you're still paying $200–300 per month. That's a big difference between serverless classic service. So in a nutshell, it's less responsibility. It's more you focusing on your services instead of on infrastructure. And, well, I already mentioned some services, some serverless services. These probably sound familiar to you. We have S3, LAMBDA, DYNAMODB, API Gateway, and CloudWatch is one maybe not mentioned today, but that's monitoring and log management, also as a serverless service by Amazon. And we'll touch on all of these today, but there are many more. So, as part of the of showing how easy serverless is, we will build a Slackbot from scratch. We don't have anything yet. We have an empty account. And I already showed you the general architecture, but this is what we're going to build. So step one in building this Slackbot is starting with an IAM role. Now, who of you here is not familiar with IAM? A few. IAM is Identity and Access Management, and it's the AWS service, again, that takes responsibility of managing who can access what. You have users that you can have in IAM. You have also have roles, and roles are things, it's a definition of what a system or a human is allowed to do. So, for example, if you have the role police officer, then you have a lot of things that you're allowed to do. You can stop traffic and drive through red lights. If you have the role basic person, then you don't have those rights. So that's how roles work in IAM as well. So first we will define a role that will be used by the Lambda function. So it will define what the Lambda is allowed to do. And what we will allow to do is write logs in CloudWatch, because it's nice to have output, and read-write from the DynamoDB table. And the role is required to create a Lambda function, which is the reason why we will do it first. This is an Amazon console environment. As you can see there, this is the AWS Lambda environment, and it says, hey, there are no Lambdas yet. But as I said, we'll start by going to IAM and create a new role. Create role. We'll say Lambda is the thing that's going to use this role. And I already predefined some policies, one of which is CloudWatch. Filter by my own. This one is CloudWatch read-write, and if we fold that out, I hope this is readable for everyone. Well, what it says is allow to create a log stream, create a log group, and put log events. So this is just a default document, or not default, but a predefined document that says we're going to allow interaction with Lambda. So I'll just select that. And I said we also want some interaction with DynamoDB. So I also prepared that. DynamoDB read-write. Well, it's the same ID. It says here DynamoDB query and everything that has to do with items. So we'll select that as well. Review and call it my London role, because I'm currently in the London AWS region. Then we've created that role. And now we will create a Lambda function. So the only requirement that we actually had was to have that role. And we'll start by creating a Lambda function that will print incoming data to CloudWatch logs. So just to show if it works. It's not functional, it's a skeleton with the very initial functionality, just to, well, get the basics. So I'll go to the Lambda console, click create a function, call it my London function, use the Python runtime and choose an existing role, my London role, which is what I just created. There's multiple Python, so you can use .NET, Go, Java, Node.js, or Python, but I'm a Python guy, so let's do this in Python today. Now the function has been created, and it has some default code here already, which does almost nothing. Let me see if I can zoom in a bit more. Font size. There. Well, this does almost nothing, but I've prepared some scripts. This one looks almost like the same as the default function, but I added just a bit. I said print event, which will print the incoming data to this Lambda function to CloudWatch. That's really easy. And then it does some other stuff as well that we will only use later. So I'll just copy this, paste it in here. I'll just remove this for now and save it. Now I can test this function, but let's skip it for now because we'll see it work in a second. So I said the Lambda function will print incoming data to CloudWatch logs. That's literally everything that we did for now. Next up is to create an API gateway to make sure that we can access the Lambda or execute the Lambda using an HTTP request. So the API gateway will be responsible to receive those HTTP requests and then forward everything that it receives literally to the Lambda function. So that's step 3. We'll go to the Lambda to API gateway. There's nothing here yet. Click Get Started, and just create a new clean API and call it My London. Oh, that's full caps. My London API. Click Create. Now it says we have a resource which is /, which is just the basic clean domain, and we'll add a method to that, and we'll call it any. So you can see here in the list, you can use the delete, get, and so on methods, which are just basic HTTP methods. Well, in this case, we don't care what you do, whether you do get or delete or whatever. We want to send everything to Lambda, and that will handle the request. So we'll just select any, and then select Lambda function, say use proxy integration, which means that all the data will be sent to Lambda, and click select the Lambda function here. Click Save. Okay. Now we can deploy this API, which is one additional step that you have to do, to a stage. This is so that you can use a dev and a production stage and maybe an acceptance stage, where we only need one for now. We call it test, and that will create a URL. Now, if we click this URL and open it in a new tab, it already says hello from Lambda. It's very small on this screen. I'll just increase the size. It says hello from Lambda. So we literally, I think, had maybe 30 clicks in the console, and we already have an HTTP endpoint and a Lambda that executes it. So if we go back to the Lambda and the London function and look at the code, you'll see here the body is hello from Lambda, which is exactly what we saw in the console. Now if we go to CloudWatch logs, we'll see the London function here as well. Click it, look at it, and here we have logs that say the request started at 1722. This is the data that we got, which is the print command that I added. It's a lot of JSON, a lot of information about the request we just received. Then it says it ended here, and this is how long it took and how much memory it used. So all of that works pretty much out of the box. So we now have the API gateway. Let's make sure that Slack can communicate with our Lambda. That's a bit more involved, but then again, it's not AWS technology, so what can you say? We'll go to slack.com/something like this. I already have some bots, so I have to create a new one, create a new app, and call it Kabisa app. And then I have to select a Slack workspace, which is just a Slack environment where the application will be installed. Well, I have a Slack environment called Luc test, so let's place it there. Then we can add a bot user. call it Kabisa. Let's call it Kabisa. Then we can chat with the Kabisa user, which is actually a bot. So we have now created that bot user. We can go to event subscriptions, and this is where you configure that everything that happens in Slack, everything that you want to forward to your bot, will be forwarded to that. So everything that happens is called an event, and our web server will have a subscription to those events. That's why it's called event subscriptions. You have to enter a URL. So we'll take this one that says hello from Lambda, enter it here, click, and then it says error. Your URL did not respond with the value of the challenge parameter. So what Slack says is, we'll do a body, and we'll do a post, which has a JSON body, and we'll send just some data, and we expect you to return exactly the data that's in challenge. If you do that, then you're proving that you have control over this URL and that this URL can actually receive Slack data. But what you send is hello from Lambda, which is not what we expect. So that's the next step. Looking back at the slides, we'll have to configure the Lambda. So the extended Lambda function, which is extended compared to the previous version, will respond to the Slack challenge, parse incoming messages, and echo any received data. And by echo, I mean literally echo. So I say something to the bot, and the bot says it right back at me, which could be annoying, but let's just use it as a demonstration. So I already prepared this, of course. This is the code that we will use. Starting from the top, it will take the body that is being sent to it. Then it will print some information saying this is the type field that Slack provided. So it will provide us with some sort of type. And if the type is URL verification, then we want to return the challenge, which is what we just saw. That is what Slack expects from us. So we'll return status code 200 with as body the challenge that we just received from Slack. So we'll just take this function, go to Lambda, paste it, save it, go to the Slack API again, and click the retry button. Verified. So now we did exactly as Slack requested. Then I said it would parse the incoming messages and echo any received data, which needs a bit more work. So first, we need to make sure that all the messages that you send in Slack, that you communicate to the bot, are actually sent to our web service. And we'll do that by subscribing to bot events. So we'll add a bot user event. It's called message.im. And it says here, a message was posted in a direct message channel, and click save. Now all we need to do here is install the app, install app to workspace, authorize it. And then if we go to Slack, oh, I missed one step there. We now see the Kabisa app, which is awesome. If we say hi, it will say nothing back because we haven't configured that. But now if we go to CloudWatch and we filter the events from the last 30 seconds, this takes a few seconds to process. The actual function has been executed, but it takes a few seconds for the logs to appear in CloudWatch. But here it is. It says, hey, we got a type field from Slack, which is event callback. And this is the data that we got. Well, there's quite a bit of data. It has some tokens and some information about which workspace it was and the timestamp and lots of information. But right here it says text, hi. So we're already receiving the messages that we're putting in Slack, which was hi, in our environment. So now we have to extend the Lambda to make sure that it actually responds. And this is, well, a bit more involved. What we're going to need to do is configure the bot token, which is a security token to make sure that we are actually allowed to talk to Slack. We have a Slack URL, which is the URL that we need to talk to and which Slack receives messages. And then we say here, we just saw in the logs that the type coming in was event callback. And if the event type is a message, then we'll print the received message to CloudWatch. And then we'll execute the function send message. And then we'll say you said, colon, and then exactly what you said. And the function send message is this. It just has some general information. It creates some headers, and then we do a request to the Slack URL with some headers and some data. And the data itself is this. It has a channel and some text. So let's copy paste this to Lambda, save it, and then there's one additional step, which is that the function requires the bot token to be configured. So here in the environment variables, we'll put bot token, and we have to copy that from here, paste it there, save it, then say hi again, and then it says you said hi. So we're in, let's see, 27 minutes. We did an entire explanation of what serverless is. Maybe we spent 10 minutes on the bot and we already have a response, and we did nothing with infrastructure. So this is an actual functional bot. But let's extend it a bit further, because something that just echoes what you're saying is not super functional. Go ahead.
Does Slack use OAuth or just token authentication?
Token authentication, yeah.
Because I think it said OAuth on the Slack page, right?
Yeah, I think it has a OAuth access token, so in the background it will use OAuth, but all you require is the access token. And you can see it in the function. This is what you have to do. You have to send the authorization header with which says bearer and then the bot token, that's all. I think technically it's OAuth, but a real simple version of it. So that was step 5. We have a Lambda that echoes any received data. So just echoing it, it's not super functional. What would be nice if it responds with a predefined text to certain trigger words. So maybe you say hi, it says hello, instead of just echoing you. Well, to create some database that says what responses are matched to what trigger words, we'll have to create a DYNAMODB table which contains that data. So we'll go to the next serverless service, which is Dynamo. It's also empty, so let's create a table, call it responses, give it a primary field, which is trigger, and add a secondary field, which is response. Click create, and then wait for a second. And there it is. Then we'll create an item, say if the trigger is high, then the response is hello. But we'll also add a second one, say if the trigger is high, we'll respond with Guten Tag. We'll write it with the caps, so it's very German. So those items are in there. Now let's look at the Lambda again. This was all that's required to create the DynamoDB table, right? It was literally, again, maybe 10 clicks. So let's complete the Lambda function and make it check the DynamoDB table for responses and send a random response of what we just defined back to Slack. So looking at the function, it's still much the same. So we have the URL verification, it's still in there. It's the message that's still in there. But now we have the function reply to text. Okay, reply to text, what does it do? It connects to DYNAMODB, takes the table responses, which we just created, and query it for anything where the trigger key equals the text that it just received. And then it sends a message back to Slack, which is a random item from the responses it got. So let's copy that to Lambda again. Close the tab. Paste, save, and let's say hi again. Hello. It's no longer echoing it, it's getting it from the database. Let's say hi again, because we included a random, and there we have the Guten Tag. Say hi again, and we got another hello. It's random, so it should do the same twice again. Like here, it says hello. Anything else you want the bot to respond to? Anything you would like it to say, or do you just believe that this works? Yeah?
More German words.
Yeah, you want to talk German to the bot? We can make it very German. But you have to give me you have to give me some input here, because I'm not very German.
Ooh, no pressure.
Kein Druck. We'll just ask it for its pressure. Wie geht's? And then it says kein Druck. That's good. So let's go to Dynamo again. Dynamo, tables, here's the table. Create a new item. Say wie geht's? And let's add a question mark. Let's be a bit kind about it. And say kein Druck. Save. Go to here. I say wie geht's? Kein Druck. It really is that easy. So, still, this is nice. We have the function. We have a DynamoDB table that contains the responses. We can send the response back to Slack. That is how easy it is. Again, we're about half an hour into the presentation, so it's quite easy. But it's not super functional, right? Because, well, you can say a literal hi, but if you say hi with an exclamation mark, then it doesn't understand it anymore, because it really needs the exact letters that you're sending. So as a chatbot, not that awesome. You need some, I suppose, machine learning and stuff. I heard somebody say machine learning earlier tonight. But that's more complex, of course. Then you need some additional services. But what could work, what could be a real practical example, is do some stuff with SQS. Who here is not familiar with SQS? Okay, quite a few. SQS, simple queue service by Amazon, is literally a queue. It's also a serverless service. And a queue, well, works like any queue. You put something on it, and something else can take it away, take it off that queue. So if you have one item and the next item and next item and next item and so on, that's 10 items. Then you take the one from the top that has been added first, and then take the second, take the third. And that's a system that you can use to decouple services. Well, a very common example for queues is video processing. Take, for example, YouTube. If you upload a video, and then YouTube is going to convert it to all sorts of different resolutions and so on. Now, if you would not use a decoupled system, then you would upload the video, and then you would have to wait for maybe 5 hours for YouTube to respond, hey, we got your video and we converted it to all of these formats. Well, that's not what you want. So what you do is you upload the video, and YouTube will put something on a queue, say, hey, we got this new video, you need to convert it. And then it responds back to you, hey, we got your video, we're done, we got everything that we need from you. And then in the next hours, it will convert those videos and maybe send you an email when it's done. So that's a decoupled system, and that's where queues are being used, to put a message somewhere to be picked up by another system, so that you don't have to wait. Now, in our example, we might want to put something on a queue through our Slackbot. So maybe you have your pipeline. I already mentioned that as an example before. Maybe your Jenkins system. You could have a Slack bot to put something on a queue, say, build my awesome app. But you don't want to wait for the response until that app has been actually built. You just want the bot to say, okay, thank you for your message, we'll start work on it. In the background, you can put the keyword for your specific app on the queue, and then maybe Code Pipeline or some other Jenkins or pipeline system can take it from that queue and take it from there. So let's build that. First thing to do, of course, is create an SQS queue. And we discussed IAM and we discussed the roles. We showed that it has access to Dynamo and it has access to CloudWatch, but it does not have access to SQS, so we need to add that. If we don't, then it's never going to be able to do any interaction with SQS. So first, we'll move to the SQS part in Amazon. Click, call it my London queue. I'm very creative with my words today. Queue. Click Create Queue. Literally take all the default options and then copy the URL. We're going to need that in a second. Then I said we need to go to IAM to actually give it permissions. So we go to the role. We have a London role, which is here. And then we'll attach a new policy. I also prepared this one. It's called SQS read write. And if we look at the permission, it says allow to SQS send message. So let's put something on the queue and get queue attributes to get some information from the queue. Click that, attach it, and that's that. Then let's look at the slides again. Next step to take is to extend the Lambda. So what we wanted to do is, from Slack, add an item to the queue and count the amount of items on the queue. So this, take it again from the example of a build pipeline. Maybe you want to know how many items are in the queue for your build pipeline. It's a common thing to request, but you also want to be able to add new items to the pipeline. So that's the two things that we're going to let it do. This is the last version of the script. So let's look at what it does. This is still the same. We still got the URL verification, the message, the reply to text. But in the reply to text function itself, it says if the text brought to lowercase starts with add to queue, colon, then we will take everything that's behind the colon and add that to the queue. So if you say add to queue, I'm awesome, then it will put I'm awesome onto the queue. If you say add to queue, build my app, then it will put the literal text build my app onto the queue. After it did that, which is something that should be super quick, then it will send a message back to Slack saying added item to the queue. Another thing, another example, another command is if you send queue length, also with starts with. So if you say queue length with a question mark or 2 question marks or whatever, as long as it starts with queue length, it will fetch the queue length from SQS and return that in a message. Now looking at the function itself, these are the functions to do that. So literally it's SQS get the SQS resource, get the resource by SQS queue name, and then send a message to it. And for the programmers among you, this is not the best code, because I should have taken those 2 lines outside and put them in a separate function. And then this function would literally be 3 lines, which could also be 1. And this one will also be 1 line. It's really that little amount of code that you need. So let's copy this to Lambda. But now you see it requires the variable SQSQ name, which I copied before. And the SQSQ name is set here. It needs to be provided in the environment variable SQSQ name. So let's scroll down a bit. Copy, oh, not that. Copy SQSQ name. Put it here. And then copy the thing that we just, the queue name itself. It's a URL. Save that. And ask I'm going to talk German to my bot now. I'm asking the bot queue length. And it says number of items in queue 0. That makes sense because we put nothing on the queue. So the command that we defined was add to queue colon, let's say the Kabisa meetup is awesome, exclamation mark. Send it, and it says added item to the queue, the Kabisa meetup is awesome. Let's ask it for its queue length again. There's 1 item on the queue. So now we have bot interaction with a queue. It's super secure because you can only send to the queue what's allowed through the bot. There's a filter and so on. You can't actually reach the infrastructure that's behind it, and it's completely functional. Now, if you have your Jenkins server or your code pipeline, you can just take things from the queue and be completely isolated from the Slackbot. So that's a very nice architecture.
Can you show the item in SQS itself in console?
Absolutely. So let's go to simple queue service. Here's the London queue. It already says messages available is 1. Then queue actions, view messages, start polling. And here it says the Kabisa meetup is awesome. I can give another example. Of course, we can say another time, add to queue. We can use caps if we like. We can write queue in some sort of breezer language and say breezers. And it will still work because it will convert it to lowercase, so it just doesn't care about how you type this. And let's ask it's for its queue length again, and now it says 2 items on the queue. So completely functional. So that was the Lambda. 2 slides. I didn't count my clicks, but it were many, and it's done. So a thing about cost, because now we built this entire thing. We have API Gateway, we have Lambda, we have DynamoDB, we have SQS, and we have CloudWatch. So we're literally using 5 services now. So what would be the cost of this bot? Well, Amazon has the free tier, and there's 2 types of free. There's the first year free, and there's always free. First year free is for new accounts. As soon as you start your account, in your first year, you get a lot of resources to get familiar with Amazon. RDS is part of it, EC2 is part of it, some machine learning things are part of it, recognition is part of it. So you can get a lot of experience with Amazon for free. But there's also another type, and that's the always free part. Amazon says this is so critical to your environment, but also you can't use your environment without it. But these services by themselves are not functional, so we're provided for free in the hopes or the knowledge that you will use all the other services that are not free anyway, which are DynamoDB. This is just an example. There's more that's always free. But DynamoDB will always allow you the first 20 gigabytes of storage for free. It's quite a lot. Also, 200 million requests per month. 200 million, that's really a giant amount of requests. And of course, if you have an application that has 50 DynamoDB tables and it's used a lot, and every request has to get some data from that table and some data from that table and so on, then maybe every request does maybe 30 DynamoDB requests. So then it's going to go a bit faster. But still, if it's 30 per request, then you still got like 66 million times that you can execute that before you reach the 200 million. That's not correct. It's I'm 6. I had 1 0 wrong there. But still, 6.6 million requests per month. So it doesn't even it resets every month. Lambda, 1 million requests per month. So every time we have an interaction with this bot, is 1 Lambda execution. So we can do that 1 million times per month for free. And CloudWatch, you can store 5 gigabytes of logs. Well, 5 gigabytes of plain text is also a lot of data. And in the first year, you get 1 million requests for API Gateway for free, and S3 5 gigabytes of storage. And then after the first year, you're going to pay for it. I'm not sure about, I don't know the pricing for S3 from the top of my head, but from API Gateway, after the first year, your first 1 million requests will cost you $3.50 per month. So it's not super expensive. Now take this bot as an example. You could configure this bot to receive every message that's in Slack in every channel to see if there's something to respond to. Let's say you have a very well-used Slack environment with maybe 1,000 users. That's, I think, a lot for Slack in general. Then those 1,000 users would each have to send 1,000 messages every month to get to the limit of what's free. And, well, I don't know how interactive you are with your Slack, but I'm sending a lot of messages on Slack, but I'm not reaching the 1,000 per month. I hope. I hope I have better stuff to do. So, in conclusion, this bot, if you use it quite extensively, is free in the first year. You don't pay a cent for your infrastructure. And in the second year, you're going to pay $3.50 per month just to have this interaction. So it's quite cheap. And that's going to be my conclusion as well. I've showed you today that for those services, I had to configure literally no infrastructure. I did not configure a firewall. I did not configure a network port. I did nothing with ports at all. I don't have subnets. I don't have route tables. Even my security, well, it's a Slack bot, so it's quite public. So, but still, I had to configure nothing. Also, I spent, well, about 50 minutes now, a lot of which was talking, to create a super functional bot that you can actually use in your use case. So it's also very easy to do. And then there's the cost, which was my last point. It's pretty much free. So what's not to like?